Today's lesson is going to focus on linear equations. We are going to kind of do a rapid review because this is something that's heavily emphasized in Algebra 1, but I like to kind of just tie it together when we're in Algebra 2 just to see if there's any loose ends. So as you recall, slope-intercept form is probably the one that you're most familiar with, and its formula is y equals mx plus b, where the b stands for your y-intercept and the m is your slope. And the reason we use that a lot is because most word problems, when you have to make a prediction, you need to know where you're starting, so how much money do you have to start out, and how much is it growing or decreasing by. So you can see this is in slope-intercept form, and from that we can easily tell that the y-intercept is at 1, so we put a dot on the y-axis at 1, and we're going to rise 2 and run 1 to the right, and there's your line. So less popular, but still a form, is standard form. And it looks like ax plus by equals c. If you want to get the x-intercept very quickly, you just simply take your c divided by your a. That is the same thing as putting 0 in for y and solving the equation. So you could put 0 in here. This is going to go away. The by is just going to go away. So if you want to get x alone, you have to do c divided by a. And vice versa. If you want to get the y alone, all right, the x will go away, and you'll do c divided by b. So I have an example right here. If we want the x-intercept, we just pretend that this guy's really not here, right? And if I do 12 divided by 4, I'm going to get 3. So my x-intercept is 3. My y-intercept would be 12 divided by 3, which would be 4. So then I put a dot on 3 on the x-axis and a dot on 4 on the y-axis, and I connect. And that's the graph that we get from that. And if you would happen to solve for y in this equation, you're going to get negative 4/3 x plus 4. You can see that is matching my line. The y-intercept is 4, and it goes down 4, right 3. And then we have our point-slope form, which is less popular, but actually a lot easier to use in my opinion. That's what it looks like. And I want to show you where it comes from. It's so simple. So normally we know y2 minus y1 over x2 minus x1 is the formula for slope. So this is a formula you would have used last year. If you were to multiply both sides by the denominator, there's nothing wrong with that as long as you keep it in parentheses. But if you do it to one side, you have to do it to the other. If you do that, you'll find that your x2 minus x1s kind of cross-reduce with each other, and they just become 1 and 1. So we just kind of drop them, and we're left with point-slope form. So it's really just a modified slope formula is really what it is. But you can definitely see the slope of your line very easily, and you can also tell me a point that's on your line. So for example, if I see y minus 3 equals 1/4 times x plus 8, I know that negative 8 comma 3 is a point. And here's why. If it says positive 8 and the formula says minus, then that means you had to have plugged in negative 8 right here. So that means negative 8 is an x value. All right, and then just regular old 3 is my y value. That's someone plugged into this formula, and my slope is always going to be out front, and it's 1/4. So normally I would plot the point, and yes, I did run out of grid a little, but it's not too bad. So I'll plot my point, negative 8, 3. I'll count my slope, 1/4, and I will connect. So each form is a little more convenient. I don't think standard form is very convenient for most problems, but I do like point slope and slope intercept. So we'll cover a couple different scenarios, and you can see how each form kind of emerges from that. So a line has a y-intercept of 4. So right off the bat, I'm going to write b equals 4. And the slope is 5, so I'm going to write m equals 5. So this is kind of like a gift. So if you get the intercept and the slope, you have enough to write slope-intercept form. Y equals 5x plus 4. If you want to turn it into standard form, you have to have your x's and y's on the left and everything else on the right. The only problem is the definition of standard form, and I don't know why this is the definition, but it is we want our x values to be positive, and right now it's negative 5. So all we're going to do is we're going to change it into positive 5x minus y minus or equals negative 4. So whether you have minus plus plus or plus minus minus, it doesn't matter. They're equivalent, but this is the form that would fit the definition. The last one, slope or point slope, might be a little confusing because you definitely have a slope, but a lot of kids don't realize that the y-intercept, this value right here, is actually a point. It's the point 0, 4. So you actually have enough information to use point slope form. So what I do for point slope form is I just simply put my x value in right here for my x2 spot. I put my y value into my y2 spot, and I put my slope in the middle. So M for middle. You could switch it. You could put the 0 in this x spot and 4 in this x spot, but then you have like negative y's and negative x's, and normally kids don't like negative letters. So I try to keep it like this so it looks a little bit friendlier. Right. Next case scenario, we have a slope of negative 6. And I gave you the 0.5 comma negative 1, and that is enough information to write a linear equation. So, good rule of thumb, if I give you a point and a slope, it makes sense to use point slope form. So if I put negative 1 in that y spot, minus negative 1 becomes positive 1. And if I put 5 in this spot, I'm just going to have x minus 5, and then my slope goes in the middle. That's point slope form. We can easily go from here to slope intercept if we just simply distribute and then subtract 1 on both sides. So negative 6x plus 29. And then if we want to go from here to standard, we're just simply going to add 6x to the left. So now everything I want is on the left, and my 29 is already on the right, so I'm done. So this is where I pause because I think this video is long enough. In my next video, I'll go ahead and go through number 3 and some of the other problems.